and welcome to the 5th and final week of the Stiles Manufacturing Solutions series. I'm Christina Elsenbrook, and I'm joined by my colleague Andrew Swanson.
Happy to be with you, Christina, and happy to have all of you join us.
Throughout this series, we've explored panel processing, digital solutions, CNC, and surface technologies.
This week, our focus is on processing solid wood.
We are excited to share how our rip, chop, and mold solutions can take your manufacturing to the next level.
No matter what your application, Stiles has a solution for you.
To help us explore our solid wood solutions, we're joined virtually by Chuck Carter, Product Manager at Stiles. Chuck, welcome.
Thank you for having me, Christina. Happy to be here.
Let's dive right in. Chuck, tell us about the Stiles Solid Wood program.
All right, so Stiles Solid Wood program consists of 12 of the, leading brands in the industry. Such brands as Homag, Vertonghen, Salvador'S, System TM, Minda, extensive Kentwood product lineup, and many, many more. Now, what these bring to the table is a solution for just about any application. So applications that require molders, rip saws, chop saws, tenoners, you name it, we have it covered. So when you take those type of solutions that match the applications, you combine it with the reliable support network that Stiles brings to the table, you have a tremendous value.
So what will we be seeing today?
Well, Christina, we'll be visiting various solid wood showrooms to see some of these solutions in action. We certainly don't have enough time to see everything that we can offer, so we're specifically going to focus on the basics of rip, chop, mold. So up first, we'd like to take you to Texas. There, we're going to see some rip-to-width solutions featuring one of our CML rip saws with our product specialist, Mr. John Barnes.
Good afternoon from Capel, Texas. I'd like to welcome you to our showroom here in the Texas area. My name's John Barnes. I'm the solid wood and sanding product application specialist for the region. I have here with me Wesley Filyaw, our senior solid wood technician. And we're going to walk through some of the equipment today and show you a little bit of the technology along with applications and why you'd want to make that change. Thanks for joining us. Let's head off to the first piece. So we're at the CML rip saw. This happens to be a two-moving blade rip saw. We also have an in-feed on it. The CML has a full breadth of product from a entry level similar to this with a fixed arbor all the way up to a 500 foot per minute 6-moving blade, 2-moving hogger rip saw. So they have a complete breadth of scope in the ripping industry. They've been around for a long time, over 50 years, and are one of the leaders in the world on rip saws. This specific one, as we talked about, has 2 moving blades. So we're starting with a fixed and then 2 moving blades. The benefits here is each board that I lay up, as I lay it onto the saw and the in-feed, I can create an arbor specific for that board. That way I'm not moving and making changes. If I run a table saw, I can get that optimization, but it's one board at a time. I pick the board up, I rip the board, I bring the next piece back, I make an adjustment to my fence. Same thing with a straight line rip, only it's higher level of productivity. Here, I throw my board up, I rip it, and I'm done. I've got a good board that's 100% usable, and it's very accurate. So I can increase my productivity technically at least 3 times faster than what I can do with a straight line rip. Plus, with the optimization, I'm not relying on my operator to make those decisions. I'm having sensors and a computer to make those decisions. So let's dive in a little bit deeper into the rip saw and some of the key components. So like we talked about with the moving blades, but if you notice, they also have this shoe. So this shoe moves with the blade in and out so that I maintain complete control. CML has a really patented, unique design, especially on these lower entry level, where my holding point is specifically here on the blade. These rollers, if you look, have springs on either side, allowing this roller down here to be able to pivot to capture the wood. And I'm putting all my pressure at the rip point, versus some other manufacturers hold down here, and when the blade cuts, when it releases stress, it ends up twisting at the blade. Causes some blade wear. It also doesn't give you as clean of a cut. This maximizes that. The other specific thing to CML are the chains. So most people use a prison system. Here we're using a series of gears and alignment. So I've got an open chain, so if something gets damaged here, I can easily pop it off and replace it. Also, it allows for significantly less wear. Since it's a chain system, I'm not getting the metal-to-metal friction that I would typically see on a moving blade gang grip with a prison system. So now let's move over to the software. So here we've got the brains of the saw. Simple controller. I've got my rip list here. So these are my rip widths. I've got thickness that I need to cut, a value that assigns that says that this size is more important than the next size for whatever reason. And then I have a linear foot need, or it can be a piece count. And here we're tracking exactly what we've done. So I'm able to monitor what I'm producing just in time. Plus, I've also got just a opportunity for a random panel width. So if I'm a cabinet door shop, I'm running my stiles and my rails and my face frame components, but I'm also running a random for the panel. Here I've got from 1.5 to 3.5 is my range of different various widths. And what we have is, if I exceed a 15% waste on my rip components, it's automatically going to trigger to rip a random instead, so that I'm constantly driving my yield. It's all about fiber savings at this point in time.
Thank you, John. We're back with Chuck Carter.
So John showed us some interesting things about that CML solution. Are these things unique?
Yes, John did point out several unique things about the CML and the Ripsaw solutions they bring to the market. These things kind of relate back to the fact that CML has been making Ripsaw products for over 50 years. So located in the heart of Italy, CML is very passionate about woodworking, and especially about the Ripsaws. And that is the only product they make. So they do it, and they do it very well.
So CML has a solution regardless of application?
Yes, they do, and we're happy to bring their solutions to North America.
Let's transition to a different sawing application, chop to length. Can you tell us about Salvador?
Of course. Salvador is one of our best solution providers. They focus, like CML, only on chop to length solutions. So one thing, and they're very passionate about the one thing, and they're also located in the heart of woodworking in Italy as well. So today we're going to go down to North Carolina. There we have another product specialist that's going to walk us through some chop solutions there. He's going to be talking about two different solutions there, push feeding and through feeding chop saws for us.
Hello, my name is Addison Fox. I'm the solid wood product specialist here at Styles Machinery, and today we're going to be talking about THRU-FEED optimizing crosscutting. So if you'll come with me, we'll take a step to the front of the machine. So this is the operator area. You've got a dual zone on this machine. You can stand on each side of the conveyor belt, and here all the operator's going to do is mark the defect. That's the operator's job, is to mark the defect on the workpiece. You can see here we've identified the two defects and the rest of the board is clear. So once we do that, we'll take a look here at our cut list. So now I've got the length programmed into the machine. Here's my lengths. I've got the amount that I would like to cut for each one of those lengths. I've got the amount done, and we assign that length to an ejector. In this case, we want to make 16 inches a higher priority than 16.5 because I need 250 of the 16-inch long pieces. So now I can change that value to prioritize the shorter pieces with the higher priority, because our mathematical algorithms are always going to be looking for the longer work pieces. So now we'll take a step inside of the machine and look how it functions. So as you can see, we got a transport belt that runs through the machine. I've got hold down rollers. I've got powered table rollers from above, 3. Very aggressive feed system on this saw. And this is my saw envelope area with a 10 horsepower motor to make that cut on the workpiece. Then the material's transported out by the transport belt. And as you saw in the software, now we can assign each one of those cut lengths to the different kickers. In the cut length, we've assigned longs with shorts. The reason that we do that is it doesn't take that operator a long time to identify a shorter piece versus the longer work piece. That's why we group those together. As you can see here in an optimize and push feed saw, I have a pusher. This pusher is connected to basically a blue light that's going to pick up my fluorescent crayon mark that I'm going to mark my defects with. The red laser is measuring the length of the workpiece on this sensing device. Now, a couple things that's important on an optimize and push feed saw. The saw needs to be sized with the longest length that you want to cross cut. This saw is set up to run a 13-foot long maximum length material. We can also do saws sized to 16 feet and 20 feet as well as standard products. Another thing that you'll notice with the optimizing push feed saw, since I'm using my pusher to place the workpiece, typically we get more accuracy out of a push feed saw. Because as you can see, I'm not relying on any type of feed works from above or below as compared to a THRU-FEED crosscut saw. Thus, I can get more accurate parts off a push feed crosscut saw. As you come with me, same type of computerization, optimizing screen where we enter in our length, the amount we would like to cut, the amount that has already been cut, and then we can assign ejectors to those different lengths as well too. As you can see, this is the end feed portion of the saw. The end feed's on a 30-degree angle tilt. So why is a 30-degree angle tilt important? Mainly when I drop that off, it's taking my workpiece straight to that fence. So I'm using gravity to help keep that placement up against the fence. And I also have a side pressure device. Now with my 30-degree angle and my side pressure device, this is going to allow me to cut the most accurate cut possible. As you can see in the outfeed, we have a takeaway belt. I can also place an inkjet printer so I can print different types of characters on my workpiece if desired. And then I have 3 kickers, again, that I can kick off those workpieces into a bend, depending on that length of that workpiece. We can also let the material run off the end of the belt as well too. So let's just say you had some longer scrap pieces. I can just let those longer scrap pieces run straight off the end of the belt into like a waistband or conveyor to take that to a waistband or some type of other grinder. Of pack cutting, which is an advantage for a push feed saw versus a THRU-FEED. A THRU-FEED you cannot pack cut. So as you see here, I've got 3 pieces of material staged in a column. Applications for this could be creating packaging material, pallet material, where I want to cut multiples at one time. I'm not concerned about the defects. You can also see as we cut it in this video, we have the narrow pusher for cutting one column. I can also add a wider pusher to cut multiple widths at one time, multiple pieces.
So Chuck, we've seen 2 types of chop saws from Salvador, push feed and THRU-FEED. Why might we need one over the other?
Well, it's basically to do with accuracy and capacity. So a push feeding chop saw is going to give you the accuracy. You have a pusher that's pushing the wood controlled through the machine, and we can take precise cuts and get a very good accurate, say, board length there. When we look at a through-feeding solution, it's about capacity, because now we're transporting the board not with a pusher, but we're transporting the board with rollers and belts. So there's always to be a little bit of slippage there. So it's not going to be as accurate, but we're going to run much, much faster than a typical push feeding chop saw.
That's great. Thanks for explaining, Chuck. So what's up next?
Well, what's next is we're going to talk about our molder program. So Stiles brings to the table two brands of molders. We have our traditional Kentwood brand. The Kentwood is our push-button machine. It's big, it's robust, it's been one of our best-selling products here for the last 15 years. And we're going to go and dive a little bit deeper into that product to learn what standards that we bring to the table that others only provide the customer as an option. Then we're going to back up and we're going to take a look at the HOMAG solution. The HOMAG Moldtech molder is a CNC molder that brings a plethora of technology to the table. So you got a lot of digital solutions there, different things that you just don't see in the industry that helps the operator make a very professional profile very quickly, very accurately. So to get things started off, we're going to go back to Texas. There I have John waiting for us, and he's going to take a look at the Kentwood molder to start.
So we're in front of a 509 S-Class Kentwood molder. So we've got 5 spindles, bottom, right, left, top, and bottom. The S-Class is our standard class machine, ideal for cabinetry, small millwork, light duty. It's a very robust machine, and as you'll see as we move forward, it's got a lot of simple technology to make things easy for you and your operator. And really what we're looking at is we're going to take a raw board that's been ripped to dimension, and then we're going to apply a profile to it in some type of linear fashion. So we have this machine currently set up to do a standard door profile. We've got some stacked tooling, and then we'll do a tool change. So if you look here on the right head, we've got an insert head, and then what we'll do after we run our first profile is we'll adjust this up and we'll look at that again. And we'll be able to do a tool change in just a matter of a few minutes by having stacked tooling. We'll also look at our Pro-Lock spindle nuts here during the changeover process. This allows for quick and easy changing of tools and heads. Another key point on all of our Kentwood and HOMAG molders are the rail and bearing design for the pressure shoe. As you look down here, you'll see a series of linear guide bearings, and that moves this pressure shoe up and down with very little friction. Therefore, all of my control is either in the air, or in this case on the S, the spring is where the pressure is. Traditional dovetail designs, I'll get metal to metal friction. We apply grease to keep it lubricated, but then it's our normal day where it's hot, so we apply heat. Then we sprinkle some sawdust because we're in a wood shop, and inevitably it sticks. And it sticks either high or it sticks low. It never seems to stick right where it's supposed to be. I don't have that issue on these linear guides. So with that, we'll go ahead and get this fired up.
And now we're going to take a look at our CNC molder solution, the Homag molder. This is the Mold Tech M300 from Homag. So here I'm going to show you a little bit about the Power Touch control. This is the Power Touch control. It's a large 24-inch touchscreen that we use to manage the machine's setup ability, its tooling, and diagnostics, and many other things that Homag brings to the table in digital solutions. So as you see here, you see a lot of graphics here. But more importantly, if you look here, you see a profile. And that profile is very unique because that's a reindeer. So we're going to walk you through how we manage the machine setup to produce very intricate type profiles such as the reindeer. So the first thing I'm going to do is going to come over here. I'm going to go to our tool management. Here's the profile that we want to be able to produce. Now you can see multiple pictures. You can also load it in drawings. But the one thing about the Power Touch control is it has the ability to pinch and zoom. So I can pinch it to zoom in, zoom out. So if this was a technical drawing and I wanted to see some fine detail, all I have to do is pinch in, pinch out. Makes it really easy. So it's really mimicking what you have on your smartphones that everybody today is familiar with. Okay, so now let's go back to the home page. We're going to go to Profile Center. Profile Center gives you the rendering of your machine. Here's your transport system. Here's your first bottom, fence, near, top, bottom, and in this case, we have a universal spindle. This second layer, you can actually see the machine table and the fence, and the blue line represents the actual tool. The brown line represents the wood block that you're going to introduce, and you can see as we go through each station, the shape or contour that's being made on that wood until we get to the final product. If we go back to the final product here, let's say the last bottom spindle, you can see it very clearly. The blue line again represents the tool. Now you can see the profile that's being shaped. You can see the tool here, and you also have some other controls here for your table plates and different settings. But remember, this is a multi-touch screen. So I can just swipe, I can go to the top head very quickly, I can go to my side head tool. So the ability I like about this is that I can actually see the profile that's going to be produced before I profile. That saves a lot of time and a lot of money. Okay, so now we're going to demonstrate how easy it is to program your profile on the Power Touch using the software Profile Center. So if we look, I have actually removed the tool here from the last bottom. So the first thing I'm going to do is I'm going to go a little bit deeper into the layer here for the first bottom. And then I'm going to go over here to my available tools. And this is going to bring up a whole library of all your tools. Now, I got to scan through this to find the tool I want. And here it is. Here's the bottom profile. And I'm going to take it and drag and drop it. And as I load that on, I can see that my profile is changing.
All right, Chuck. We've talked rip, chop, and mold. But I hear there's a new technology out there. Is that right?
That is correct. We have some new technology with our partners at Vertangen. This specifically for the kitchen cabinet door industry. So in the last year or so, one of our hottest products has been the kitchen cabinet door work cell from Vertangen. Now, Vertangen is another European company. They're located in Belgium. They've been in business for over 100 years, so they really know how to make windows and doors correctly. So what we did is we've taken that technology, we condensed it into the smaller kitchen cabinet doors, and it's been a huge success for us. So what we're going to do right now is we're going to go up to Grand Rapids, Michigan. There we have a Vertangen work cell set up in our showroom, and I have Mr. Peter Van Dyke, and he's going to walk us through some of this technology with Vertangen.
Hello, today we're going to talk, I'm excited to talk about the Vertangen kitchen cell. I'm Peter Van Dyke with Stiles Machinery, product specialist for solid wood and sanding for the Great Lakes region. And today we're going to talk about a company, Vertangen, that's been building woodworking machinery since 1900. And specifically in the last 20-25 years, profile and tenanting equipment for windows and doors. The collaboration with Stiles over the last 3 or 4 years has resulted in a very unique machine cell that is great for the kitchen cabinet industry, something that they've wanted for a long time, to be able to profile small parts, do a door at a time. And we're going to kind of walk you through how this machine works, and we'll demonstrate it for you. As we walk over, the first machine in the cell is a tensioner. And on this machine, we have the ability to size parts so that we have nice square doors. We have a saw in the system. We have a positioning fence so that we can size pairs of parts so that we know that we have an exact square door, and the seams are square so that if you have a painted door, we're going to show you an MDF door in a little bit, that those seams are nice and tight so we don't have any cracks and you don't have to putty, that type of thing. We also have a stack tooling spindle, 300 millimeters, that allows you to stack 8 to 10 profiles on that spindle. So one of the other advantages of this is you can load up all of your profiles, do a door at a time if you like, for sure a job at a time, and be able to go back and forth from one side to the next very, very quickly and do these small parts. On the other half of the cell, over here, to the profiler. Profiler is the second portion of this cell, and because we can do small parts with a specially designed fence and infeed system, and down to 4 inches, it allows us to do all the tenanting first, which is the preferred operation, and do the profiling second. That's what allows us to have that S4S material in stock instead of profiled material. And we only have to have one backer block to do that on the tensioner. On this machine, we have the ability to go down to 1.5 inches for minimum width, and we can go out to 9 inches for the maximum width of a part. And again, with the touch of a screen, or touch of a button, we can go from one thing to the next very, very quickly. The machine is very safe, and just like on the tensioner, we have a 300 millimeter spindle, so we can put the exact opposite counter profiles for the profiling on this machine. So again, be able to go from one thing to the next, just-in-time manufacturing. So now what we'll do is we will run a door. We'll put that door together. We're going to run a very small door with 4-inch long parts. That's one of the claims to fame of this cell, so you can see that operation. Then the second video we're going to show, presentation, is we're going to show an MDF door. And that MDF door, the reason we want to show that is we're seeing more and more customers making 5-piece doors out of MDF and a lot of paint. And so because all the parts are the right length and the joints are nice and tight, we have the ability to have crack-free joints when we go into the paint shop, and we don't have to worry about puttying, etc. So we will break now and we'll run the door for you. Okay, so wrapping up here, we wanted to kind of review the kitchen cell and the benefits for you and what it can do. And as you can see, we made two different doors, a very small door with short pieces. We were able to run those profiles through that profiler, even though they were only 4 inches long. And then we've got an MDF door. And again, these doors have been perfectly sized. The joints are very tight. It allows you to reduce the inventory that you have. You can have S4S stock instead of profile inventory sitting around. You can make a door at a time. You have the ability to stack a bunch of profiles. Depending on what you want to do, if it was a repair door, if it was a small job, a large job, you have a lot of flexibility in a small footprint. One operator can produce a lot of doors. We thank you very much for taking the time today to take a look at this Vertonghen work cell. If you have any questions, by all means reach out and let us know. We'd be more than happy to talk to you about it in more detail. Thank you.
Another great solution. Thanks, Peter. Chuck, we've seen a lot today, but we've barely scratched the surface. So where can our viewers see more?
Yes, so with Stiles, we have 5 showrooms across the United States. So we have showrooms in Texas, California, Michigan, North Carolina, and Pennsylvania. We also have a couple of showrooms up in Canada. So we have an office there in Mississauga and Montreal. And all of these offices have some type of solid wood solution that you've seen today, but a lot of them have even more than what you've seen today. So we encourage, if you can travel, come and visit us at one of these showrooms. If you cannot travel, we do have a way to make a virtual demonstration for you as well.
Chuck, thanks for joining us today.
Thank you. And again, I'm Chuck Carter, Product Manager of Solid Wood Solutions at Stiles Machinery. I know everybody today is extremely busy, but you know, we have a good, strong solid wood team that's here to help you find your solution. Multiple showrooms, multiple product lines. We definitely have a solution for you.
If you have any questions for today's presenters, please visit stylesmss.com.
And complete the survey at the end of this episode. Your feedback makes our next event even better. This may be the last episode of the Manufacturing Solutions series, but it doesn't end here. Visit stylesmss.com for more information on this week's events and to watch replays of previous episodes.
We've enjoyed learning from our team of experts over the past 5 weeks, and we appreciate your participation in this series.
Andrew, it's been a pleasure hosting this series with you.
Christina, the pleasure's been all mine, and I hope you all have enjoyed it. Take care, and we'll see you next time.